Hi, I'm Chonghua Guo, founder of Chonghua Academy. I will teach you the primer of probability. Now we start exercise class 2 for more difficult counting problems. In our last class, we have learned a step-in type counting problem is solved by multiplication first and addition second. On the contrary, a type-in-step counting problem is solved by addition first and multiplication follows. So when we face such a problem, we first clarify whether it's a step-in type problem or a type-in-step problem. Let's look at assignment 1. Among a group of 7, each person can speak at least Spanish or German. If 5 people can speak Spanish, 3 people can speak German. How many ways are there to select one who speaks Spanish and one who speaks German? With 4M problem-solving approach, the motivation might be better translator resource allocation. So translator resource allocation. This is our motivation. Now, in terms of the method, is this a step-in type or typing step problem? It's not very explicit right here. So we do some analysis. According to the context, we can see that if 5 people can speak Spanish and 3 people can speak German, immediately we find that 5 plus 3 is larger than 7. This suggests there's one person who is bilingual and who can speak both Spanish and German. 4 people can only speak Spanish, 2 people can only speak German. In such case, the desired job can be done in 2 types of options. Type 1 provides us with ways to select one Spanish speaker from the 4 Spanish only speakers, and then select one German speaker from the 3 German speakers. Remember here, type 1 implies 2 steps are needed to finish the job. So this is step 1, this is step 2. Okay, now type 2, which means we can finish the job in this kind of option. Type 2 offers a way to select one Spanish speaker, so which is one Spanish speaker from the sole bilingual speaker, and then select one German speaker from the 2 German only speakers, and then is from the German only speakers. So also we remember that here there is 2 steps, step 1 and step 2. Therefore, we have 2 types of options, either of which can get the job done. And each of the type consists of steps. So we conclude this is a step in type problem, and it should be calculated by multiplication first, and then followed by addition rule. So mechanics. For type 1, there are 4 times 3 equals to 12 different ways. For type 2, there are 1 times 2 equals 2 different ways. Together, there are 12 plus 2 equals to 14 different ways to get job done. More thought. Why we ignore a loophole that a type 3 may exist? To select one German speaker from the sole bilingual speaker and then select one Spanish speaker from the 4 Spanish-only speakers. Think about it. Let's turn to assignment 2. An extracurricular activity needs 1 teacher and 1 student to be selected from 2 female teachers, 3 male teachers, and 5 female students, 7 male students. How many ways are there? The motivation might be appropriate human resources allocation. So with using our 4M approach, motivation is better human resources allocation. Let's figure out the method. As before, the key is to clarify whether it's a step-in type or typing step problem. Immediately, we find it's 2-step job. So we find that it's 2 steps. Step 1 involves in selecting 1 teacher from the 2 types of teachers, male or female. So step 2, and step 2 to select 1 student from male and female students. So we conclude it's a type in step problem whose calculation should be done by addition first and then followed by multiplication method. Therefore, we are ready to do mechanics now. For step 1, there are 2 plus 3 equals to 5 different ways. For step 2, there are 5 plus 7 equals to 12 different ways. Together we have 5 plus 12 equals to 6 different ways to finish the job. This answers the original question. More so, how many ways are there to select 1 female teacher, 1 female student, and 1 male student? Okay, now let's turn to our next assignment. Smith's couple are planting trees in their garden. They are to plant 5 saplings selected from 3 types A, B, C of saplings onto 5 tree holes lined up in the row. They want the same type of saplings not to be adjacent, and the 5th tree hole to be planted with type A saplings only. How many ways are there? Okay, let's go to our foreign approach. What's the motivation? Smith-Couple's motivation might be better looking in their garden. The method, since its content is not very explicit, we are going to try the graphic approach. First, the three types of saplings could be labeled as circle A, circle B, circle C. After the fifth tree hole is planted with circle A saplings, so we have this is fifth, 4, 1, oh, sorry, 2, so sorry, this is 3, 2, 1, and with the fifth tree hole is planted with type A sapling. The middle four tree holes look like this. So 1, 2, 3, 4. Since the same type of saplings cannot be adjacent, so the fourth hole must be fourth hole, which is this one. Fourth hole must be either B or C, which suggests two types of options. Hence, we just enumerate possible permutations of middle four by type. So we can, here is type B. Type B. For type B sapling on the fourth tree hole, possible permutations are so A, C, A, B, A, B, C, A, C, B, C, A, B, C, sorry, C, A, C, C, B, C, the file is C, B, A. Okay. And for type B sapling, we also got another permutation like A, B, A, C, A, B, C, A, C, B, B, A, C, B, A, B, B, C, B, B, C, A. This exhausts all possible permutations to plant the saplings into the 5 tree holes as desired by Smith-Couple. So we can do the mechanics by just simply count the ways we just did graph. And for this one is 1, 2, 3, 4, 5, 6, 7, 8. So we got 8, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So this one is A. And together they are 8 plus 8 equals to 16 different ways. This answers the desired question. More thoughts? How many ways are there if Smith's couple only requires the same type of sapling cannot be adjacent for all the 5 tree holes? Okay, to facilitate your further thinking, I would like to provide you with an additional assignment. There are 5 books on the shelf. Another 3 books are to be inserted in between the existing 5 books without changing their sequence. How many ways are there? You are encouraged to crack down it by yourself. A suggested answer is given in the bottom, which is 336. This ends our exercise class 2.